Alright, so here we go. Let's do number 20. And this is the practice test on page 227. Alright. Let's see. Find the distance from point P to line L. So line L contains these points right here. Negative 4, 2. And 3, negative 5. That's supposed to be a 5. So it's kind of funny. Alright, and then point P is the point 1, 2. Alright, so this right here is line L. I'll just put a little L in front of it. You know what that means, right? So it's a line. Here's a point not on this line. We want to find the distance from this point to this line. The distance is defined as what? Is the from the point where to the line? How do we draw that line? What is it? Perpendicular. That's right. Okay, so just so that we have an understanding there, let's draw X and Y axis. This is just a sketch. It doesn't have to be perfect. Okay. Let's plot these points. Negative 4, 2. 1, 2, 3, 4. 1, 2. Then we got 3, negative 5. 1, 2, 3. 1, 2, 4, 5. So let's put some points here. So it's negative 4, 2. Negative 4, 2 would be about right here. 3, negative 5 would be down here. Let's connect them. Again, this is just so that we could visualize what this thing looks like. We could extend it out. We're not finding the distance of that line, are we? No. Okay, so if we wanted to, we could extend it out. Let's change colors. Let's go to this pretty purple. Let's go 1, 2. So 1, 2 would be right here. And what we want to do, doesn't look much different, does it? Alright, so what we want to do is find the distance from this point to this line. So how do we draw it? We draw it what? You just said it a second ago. Perpendicular. Now I'm just eyeballing it. Alright, so I don't, I don't have any protractor or any tool that makes that perpendicular. I'm just eyeballing it. That's all we need. Now, what do I know so far? I know this point, don't I? I know this point because I'm trying to find the distance of this little line. That's purple if you can't tell. If you get on the computer tonight and look at it, you'll see that it's purple. Okay. What is that point right here? 1, 2. All right. What about this point down here? Don't know, because we call it XY. That's right. What we want to do is find the distance between there. So what we want to do is find this XY. How do we find the XY? Very similar to what we did the other day when we did the, or yesterday, when we did the parallel lines. We take the equation of this line right here, we take the equation of this line right here, and we basically set them equal to each other, don't we? All right, because it's y equals, we set them equal to each other. So which equation do we know right off the bat without doing any math at all? Well, actually, we got to do some math, don't we? I'm thinking of the other problem. Let's find the equation of this red one. In fact, let's go to the color red, and we'll do it all in red. So let's find the equation of this line right here. Well, that's this line, isn't it? It's line L. So let's find the equation given these 2 points. First thing we do is find the slope. I'll tell you what, I'm going to rewrite the 2 points right here so that I can easily refer to it. All right, let's find the slope. The slope is the change in y over the change in x. So we subtract the y's. 2 minus negative 5, we can do that in our head. What's 2 minus negative 5? 2 plus 5, which is 7. And then let's go negative 4 minus 3, which is, how about negative 7? And then that is negative 1. So our slope of this red line right here is negative 1. We don't want to just guess where the y-intercept is. We want to find out exactly where it is. If you used graph paper, you might see that it, but I didn't use real graph paper. I just kind of bang, 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 put the, numbers down. So it might not be super accurate, but we can just use our points to figure out what it is. So watch. It's y equals mx plus b. What's all the disturbance outside? What's going on? Okay. Oh, is that right? Okay. Y equals mx plus b. So here we go. Which point do you want to pick? Let's just pick the first one. Doesn't make any difference, does it? So 2 equals negative 1, that's our slope, times x, which is negative 4, plus b. Now we just solve for b. 2 equals 4 plus b. Subtract a 4 from both sides, so b is what? Negative 2. Let's write the equation of this red line now. Y equals, the slope is negative 1, x minus 2. Put that in a box, hang on to it for just a second, and we'll come back to it and use it. You with me on that? It's really not that much I mean, it looks like it's a lot of work, but it's stuff that we've done before. You just had a quiz on it, right? I just gave it back to you today. Find the equation of a line between those 2 points. Okay? Not that big of a deal. You should be able to do that. Now, let's find the equation of this purple line. So let's go to the purple color. I think that's the color I used. All right, so let's go to this color right here, this little line, and find the equation of this line right here. Well, I know a point, don't I? And what else do I know about this? I don't know 2 points, so I can't do the same exact thing that I did here because I don't know this point. All right, but I do know what else. It's perpendicular to this red line. Rachel, you're dying to say it. Say it.
Its slope is the reciprocal.
Oh, is it just the negative reciprocal? So we change the sign. The slope was -1 on the red one, right? So we change the sign, which is positive. We take the reciprocal. Well, what's the reciprocal of 1? It's just 1. So what's the slope of that purple line? It's just 1. Okay? So look what I got. I got a point. I got a slope. Now I can go through this and just find the equation of it. So y equals mx plus b. Let's put some numbers in. Now I'm using this point. This is the only point I know on that line, so it's the only choice I have. So I put a 2 equals m, which is just a 1, times x, which is a 1, plus b. I'm showing every step. You might be able to do a lot of this stuff in your head, but I'm just showing every step. Subtract 1 from both sides, so b is what? 1. All right? It doesn't quite look on here like it hits 1, but it's pretty close, right? Wouldn't you agree? Yeah. Same thing with this -2. Look at the red one. It's pretty close to where it should be, isn't it? If I used graph paper, it'd probably hit dead on, okay? Let's write the equation, though. Let's write it right next to this red one. So y equals what? 1x, which is just x, plus 1. Put that in a little box. Now, the reason I put them in a little box so I wouldn't forget them and I'd come back to them. You don't have to put them in a box. I wouldn't mark it wrong if you didn't put it in a box. But to me, it's just helpful, okay? I look at them like, oh, yeah, there it is. Those are the things I'm using, okay? So it's not lost in a sea of numbers and letters and all that. You understand? Now, what do you do with these two? Set them equal to each other. And why are we setting them equal to each other? Because we're finding this point of intersection between the two lines. This is the point that's in common with both of these lines. All right? It's a point that works. I'm sorry, it's an x that works for both of these, and it's a y that works for both of these. Since they're both equal to y, they're both equal to each other. That's basically a substitution property. So let's just set them equal to each other. So x plus 1 equals -x plus 2. See that? I just took this and set it equal to this. Now let's just do some easy math. Add an x to both sides. Yes? No, don't say shush. Because, yeah, you need to tell me, because it should be a minus. Thank you for that. Yep, it's -x minus 2. It should be that right there. So watch what I do. I add an x to both sides, I subtract a 1 from both sides, and I get, what? 2x equals, what's that? -3. Alright? Am I doing everything right? Yeah, it looks like it. So divide by 2, so x is -3/2. And you look at that and you're like, oh man, a fraction. But it's not that big of a deal. What's 3/2? If I'm going to put this in a distance formula, just 1.5, right? -1.5. So that's what I would put into the distance formula. So now I know what x is. Now I got to solve for y. I could pick either this equation right here, or I could pick this one. It doesn't make any difference. Which one's your favorite one? The x plus 1? Yeah, that's probably what I would pick as well. So watch. Y equals x, which is -3/2, plus. Now watch what I'm going to do. I'm not going to put a 1 here. How do you think I'm going to write it? 2/2. Good. Are you getting used to doing that now? All right, look for that kind of stuff. -3 plus 2 is -1/2, and that's what y is equal to. So what's my ordered pair now? All that work, all that stuff, just to find this point right here. But that's a very important point. All right, it's that point of intersection. So what is it? It's -3/2 and what? -1/2. Does that look? Yeah, that's about -1.5, right? And that's close to -0.5. Close enough. Yep. Again, I don't have to be exact, do I? On my graph, no. So that's my point right there. Now, what am I trying to do? What's the purpose in finding that point? It's finding the distance between those 2 points, okay? And that's what I'm going to do. So let's do this. Distance equals square root. Put a squared here and a squared here. Now, at this point, you know how I always harp on keeping it improper fractions? At this point, if I'm putting it into the distance formula, I'll probably go ahead and put it as in decimal at this point. Okay, is that all right?
Yes.
So let's see. What are my 2 points? Let's put them right here. Instead of writing -3.5 or 3/2 this time, let's write it as what? -1.5 and what? -1/2. Okay, and what's my other point? That's this point. What's the other point? It's 1, 2. You with me?
Yep.
How do we do this? This is subtracting the x's, isn't it? So subtract them. Let's go 1 minus. What's 1 minus a negative? It's 1 plus. You can do that easy. What's that? 2.5. Right? Let's do this one. 2 minus a half. Or 2 minus negative a half. So it's 2 plus a half, which is 2.5. Again, isn't it? All right, let's use a calculator. This is beyond me now. So this is, what's 2.5 squared? 6.25. Okay, plus another 6.25, right? Which is what? 12.5. So it's the square root of 12.5. Okay, and let's throw that into a decimal. What do you get? Do you get about 3.5? You get 3.5? Okay. Now you could have written these as fractions and all that without putting them in as a decimal, and you would get something else. Let's see, 12 and a half. 12 and a half is what? 25 over 2. Is that right? And it's a square root. I just want to show you how they got their answer. Would you agree 12 and a half is the same as that? Watch what they do. The square root of 25, watch, this is the same as the square root of 25 over the square root of 2. Square root of 25 is 5 over what? Square root of 2. Did you guys do this in Algebra 1 where you got rid of the, a little bit? Okay, do you remember how to do that? Multiply the top and bottom by the square root of 2. So what do you get? You get 5 square root of 2 over 2. So that's the way they write it in the book. I'm perfectly fine if you write it as 3.5. Okay? Don't do this, though. I mean, this is a rare thing that people do. I mean, most people would not combine a decimal inside of a square root. If you're going to have a decimal inside of a square root, you might as well just put it into a calculator anyway and get this, okay? But you could have done it this way. This would have been fine. I wouldn't require you to write it like this. Now, when you get into Algebra 2, though, now, I'm not teaching Algebra 2 now, but I taught it a bunch of years until this year. I'm very sad about that, by the way. But somebody else. If I was teaching Algebra 2, I would make you write it like this, okay? Because that's part of Algebra 2 to make sure you simplify the radicals and all that kind of stuff. All right, but we're not doing that now. There it is. There's number 20. How about that? Are we good?
12 minutes and 45 seconds.
Right. Now, it didn't take me... Do you think it would take me 12 minutes and 45 seconds to actually do the problem?
Yes.
No, it wouldn't. Because I'm sitting here and I'm sitting here and I'm talking. I'm talking through it, so the majority of it, if I was just working the problem, it'd take me a couple, 3 minutes. All right? Okay, so do that. Listen, your homework is that practice test worksheet thing. Okay, I gave you a worksheet. It's another practice test. You should be grateful to me that you're getting this extra practice, okay, because it's more to practice and it's more to prepare you for the test, and you should be doing better on the test the more practice you get. So I'm going to give you one in a second. All right, so that's it.